And here's task number 3. For this scenario, we're looking at Tyler, who's planning to start a lemonade stand and is trying to perfect his recipe for lemonade. He wants to make sure the recipe doesn't use too much lemonade mix, which is lemon juice and sugar, and then he's going to combine that with water to make the lemonade and then still make sure that it tastes good. We have 2 different recipes represented in 2 different ways, and then we're going to have to make sure that we represent each of those recipes in all 4 different representations. So let's go ahead and take a look at the table first, just because, again, it's a little bit more concrete and familiar. For lemonade recipe number 2, we have that X is going to be our lemonade mix, and we're comparing that to Y, the number of cups of water. And so if you set up your ratio of Y to X, you get 50 over 10 is equal to 5 is our constant of proportionality. And just to the side here, I'm going to make a note real quick of what does this mean. So 5 what per what. And I'm hoping you guys would recognize that the Y label goes in that first space because it's the Y per X. And so that's 5 cups of water per 1 cup of the mix. And hopefully that makes sense that you have to dilute the mix to make sure it's not too sour. Looking at the other representation for recipe number 1, you're given an equation. Y equals 4X. And X represents the lemonade mix, and Y represents the amount of water in cups. So if you set up your ratio of 4 to 1, Y to X, that's going to be our number of cups of water, as with the table, to the number of cups of mix. So again, we have to dilute the 1 cup of mix with 4 cups of water. And so before we answer the question, the questions in parts A through C, I'd like to dive right into the representations and look first at the tables. So if you notice, I've copied down 3 of the values from recipe 2's table, the 10, the 13, and the 21, but you'll also hopefully see that there's an additional row with 16. And if I zoom out and show you part A, we are looking to see how many cups of water would be needed to dilute 16 cups of lemonade mix. So that's why I've included that in the table. And then if you go ahead and recreate a table, but for recipe 1, use the same X values and then try to get the corresponding Y values. And so we were given the 50, we were given the 65, we were given the 105 in the recipe 2 table, and that was, again, obtained by multiplying each X times 5. So do that again for the 16, and you get 80 cups of water. If you look at that constant of proportionality we pulled out of the equation for SP1, we got that 4 cups of water are needed for every cup of mix. So that's multiplying across the table by 4 to get each of those values. And then 16 times 4 also gets us 64 cups of water are needed for 16 cups of mix. And then I'm going to go ahead and jump right into the graph since we have all the values that we need to plot this relationship. Regardless of any proportional relationship, you should always consider graphing the 0, 0 on your graph. And then the biggest X value between the 2 tables is the same, it's 21. And then the biggest Y value, if you look at the biggest values at the bottom of the tables, is actually 105. And we have a 14 by 14 grid again, so we cannot go up by 1s for the X. That will lead us to only 14, and we need 21. So going up by 2s makes sense. And then we can't go up by just, 1s for the Ys because we have really big values. So actually, if you go up by 10s, that'll really nicely capture the 105 without getting overcomplicated. And so I'd ask, as with task number 2, that you pause the video here and make sure that you are labeling your X-axis with the cups of lemonade, your Y-axis with the cups of water, and that you have these increments of 2 along your X-axis and increments of 10 along your Y would work well. And capture each of those 4 sets of coordinates very precisely and then check it against this graph. So try it on your own and pause the video and then resume when you're ready to move on to the other representations. I'm going to go ahead and move on to the other representations. If you take a look at the verbal descriptions, that's really just capturing the rate of change or the constant of proportionality in a sentence. And we did that right away. We did it from the table with recipe 2 and said that we need 5 cups of water per 1 cup of lemonade mix. And for recipe 1, we pulled that out of the equation. If you're not sure how to pull the constant of proportionality out of the equation, it's always good. You can see the constant of proportionality if you had just listed some random X's in the table and multiplied it by the 4, because that's what our equation tells us. That would have shown you then what's the y over x, which is 4. And then, speaking of, we have to do y equals kx for our equation in the last representation. And instead of k, we're going to plug in each of the 4 and 5. So y equals, instead of kx, 4x for recipe 1, and y equals 5x instead of kx for recipe 2. And at this point, we've done all 4 representations for both recipes 1 and 2, and we can use this information to answer questions A through C. You'll see that I've already made a note that you can just look at the verbal description to describe the rate of change, since the verbal description on this example captures the rate of change. Looking at part A, to capture the amount of cups of water needed to dilute the 16 cups of mix, we fit that into our table. So recipe 1 requires 64 cups of water to dilute just 16 cups. And recipe 2 requires 80 cups of water to dilute 16 cups. And that brings you to question C, or part C. And it says Tyler has a 5-gallon jug which holds 80 cups. And he wants to use this for his lemonade stand. And he also has 16 cups of lemonade mix. So which lemonade recipe should he use? And you might think like, oh, perfect, I have 80 in that second table for recipe 2. So just use that because it's a nice comparison. But that's 80 cups total. So actually, if you look at recipe 1, the 16 plus the 64 would capture 80 full cups. But because recipe 2 would use fewer cups of lemonade mix, it would be somewhere between the 13 and the 16 to get 80 cups total. You may say recipe 2 works better because you'll have leftover mix. So really part C, that's up to you. You could say recipe 1 because 16 cups exactly of the lemonade mix with the 64 cups of water will perfectly fill up the 80 cups, which is in the 5 gallons. Or you could say recipe 2 works because you can have leftover lemonade mix to then use more for your sales. And that concludes task number 3.